gallivanting around with someone else. I'm someone else. This is gallivanting. Another female companion.
So is that one?
I'm ready when you are. Alright.
Go for it.
Alright, everybody. So this is the after lunch. Everybody's like calm and well fed, and they don't want to think about super technical stuff. So that's great, because we're not going to be talking about super technical stuff today, mainly because this project is like ongoing, and so a lot of stuff I figured out, how to not do well, and then there's a lot more to come about me figuring out what does work well. So because of the state of this project, like, it's just crazy. So I'm going to talk about connecting my 1988 Ford Bronco 2 to the internet, and some things I tried that did not work, some things that I tried that worked, and what I learned, and especially, even though I may not give you all the answers, I'm going to talk a little bit about the Azure services I used and why, and how you can use them too. So I'm Jared Porcelanic. I'm super into the Internet of Things. If anybody knows me for 5 minutes, they probably figured that out. I help organize the Orlando Internet of Things meetup. So if you obviously love coming to places to sit and learn from other people, you can come to the Orlando Internet of Things meetup too. It's a meetup. So I have a 1988 Ford Bronco 2, if you couldn't figure that out from that slide. And there it is. There's a picture. Well, this is not it. This is actually a projector screen with an image projected on it of it. And I had the original water temp gauge that told me if it was overheating or not. It didn't work. It was always pegged at hot, which I don't think was true. It seemed to keep running, so whatever. So I got this gauge from what? Someone saying something? Oh, okay. Sorry, I got distracted because someone was talking back there. Anyway, so I got this gauge from the auto parts store. It's a completely analog gauge, and it's so analog, in fact, that there are no wires. It uses a tube filled with gas, and the gas physically gets heated up, and then pushes the gauge based on how hot the gas is. As you can imagine, that's not the most accurate way of figuring out how hot something is. And in fact, I'd drive around my Bronco with this gauge in there, and it would take 10 minutes before it registered anything, and then it would just like shoot up to here-ish. And if I took a poll, everyone would have a different answer on what that meant. So I was like, well, I'm not really super happy with that, and I like connecting things to the internet. So why don't I just connect my thing to the internet? How easy would that be? And so I started down a fairly long journey on making this happen. Yeah, I bought my truck for $750. It's in great condition. So here's my project goals. And I've accomplished every one of these things. So I could have went back to the parts store and bought a digital gauge and plugged it in, and I would have got a very accurate temperature reading. It would have taken me an afternoon, and I would have spent $80 maybe, and I wouldn't have learned anything. And I chose not to do that. Instead, I chose to spend 6 months or so, off and on, probably like realistically 40 hours total on the project so far. And I've probably spent $100, so $20 more than what I would have spent on a gauge that works. And it's not done yet. It doesn't send any information to the internet. Not an Internet of Things project yet. But you're all here, and I'm up here, so let's make the most of it. But I have learned quite a lot, and I'm excited to share about that. So this is my real goals. That was my joke goals. These are my real goals. I wanted to learn and leverage Azure stuff because I'm a software developer who's really bought into Azure. I really can't get away from it because they make it super easy for most things. And they make this as easy as they possibly can too. Like I don't think it would have been a 2-month or 1-month project in real time or a 20-hour or 10-hour project if I used another cloud provider. It would still be, I'd still be 40 hours in at the same place I am now if I used something else. But so it's all the non-Azure stuff that seems to be taking a long time. So anyway, I wanted to learn more about the Azure Iot stuff, and I wanted to use DevOps best practices because I really believe that this is a weak spot of IoT right now. Like people can figure out ad hoc ways of delivering code to these devices, but I wanted to understand like how do we do it in a way that's going to be repeatable, and how are we going to monitor it, and how am I going to understand how it's working and be able to update it easily. And I also wanted to kind of, in part with that, learn how to productionalize IoT. So this is a prototype. This is actually the prototype of this project. And this is, someday it might be like a Nest thermostat where I manufacture and stuff. That's like the long-term goal. Is I want to take this stupid little project and like actually kind of manufacture a nice little, pretty little package, just one, just for me, and be able to update it and do all these things, just so I can understand the process. Because there's a big need for that. Even the best, brightest, most flush people in the world have trouble with updating the stuff, their IoT stuff. A great example, obviously Nike had a problem with their shoes. And honestly, I don't want to live in a world where my shoes fail to update. And I want to help figure that out. Because, I mean, honestly, like, it would be great to have internet-connected shoes. Like, if it were free, and if it was reliable, and we didn't have to worry about it, how fun would that be? I'd figure out, like, how far I walked or didn't walk. And I think this one was self-lacing or something like that. Like, it's cool. Why not have that? But if the cost is that it's going to break, then most people won't accept that. So this is a really big problem area in IoT. It's like, how do we make it reliable? How do we make it actually, work without people thinking about it? So those are the questions I really wanted to answer with this project. Even though I also wanted to kind of measure the temperature of my Bronco also. So I'll level set with that. If I had just wanted to measure the temperature of my Bronco and send it to the internet and put code on something once to do it, I would be done by now. But because I put all these other constraints, I wanted to learn Azure, I wanted to do it in a DevOps way, I wanted to learn how to productionalize it and think about those things. It's taken me a very long time. Because I've done projects like this in the past where I have a device and it's sitting beside my computer and I can get it to read temperature and send it to the internet. And I can find a tutorial to do that in an hour. But thinking about those other things really made me think about this project differently than I've thought about those previous projects. But I wanted to make it as easy as possible for me to start out. And this is where we get into my journey of what I've learned doesn't work, or at least what I've learned doesn't work as well as I wanted to. So I wanted to start as simply as I could because I think simplicity is, I didn't want to boil the ocean trying to learn everything all at once. So I wanted kind of like the children's kitchen playset version of IoT development. So I needed some help. And so I started with a prototype, or a proof of concept rather, that used off-the-shelf hardware, Raspberry Pi, you can buy it online. It used plug-and-play hardware that I don't have to think about voltages or anything like that. So Seed is a company that makes a lot of cool stuff for prototyping. And they make this thing called a Seed Grow Pi hat, and you slap it on top of your Raspberry Pi. And what it allows you to do is literally plug and play sensors and actuators and stuff. And they also provide a set of libraries you can get from NuGet. Like if you're a C# developer like me, or C# one of the languages you know, then you can buy this piece of hardware, slap it on your Raspberry Pi, run Microsoft Windows 10 IoT Core on it, deploy a Windows app, a UWP application to this operating system. This is an operating system. And then you can use a library that C provides to read temperature from a sensor. Real temperature from a real sensor. Very cool. So I did that. And this is my little project. It read temperature, and I felt very proud of myself. And this is what that stack looks like, basically. So I had actually built this prototype with a real sensor, and I used these technologies to do it. And I was updating, because I had productionalized my application as one of my constraints, I wanted to update this as if it were a real device that someone who was non-technical would own. And so the way that works in Microsoft world is if you have Windows 10 IoT Core as your operating system, you can only run UWP apps on it. UWP apps are normally distributed through the Microsoft Store. That awful hellscape. So what's really cool about having an IoT device that runs Windows 10 IoT Core operating system is that you can do the same thing. You can distribute your app through the Microsoft Store. So I could have 1 million of these, in theory, distributed all around the world, and as long as they're connected to the internet, they would get updated. One might ask themselves, how does someone navigate to the Microsoft Store to download the app to be able to update it? Because normally, like with Windows, like I hit the start bar, I find the Microsoft Store. In this case, I'd find the Smart Bronco app, right, and I'd download it. Well, consumers aren't going to do that. So what you need to do in Microsoft land is become an OEM, which is something I did. And when you're an OEM, you can make your own version of the Windows 10 operating system. You can compile it with your app pre-installed, and that app is set up to start as soon as you start your computer. So basically I was left with me being able to plug in my Raspberry Pi, it boots up, my app is the only thing anyone ever sees, and because that app is a UWP app, and I'm an OEM, I can update it through the App Store. And everything was amazing. I was like, yeah, let's make it happen. And I had all that working. And then, well, let me show it all working. This isn't working. 77 Fahrenheit. Woo! And then I ran smack dab into the real world. So previous projects, like that's where I'd leave it at. I'm like, I did the prototype, I'm very happy, it connects to the internet, everybody. And now I'm like, okay, I actually need to put this in my Bronco, and I actually need to read real temperature. So what problems are there with doing that? One thing I found was, first of all, it's slow to update through the Microsoft Store. So earlier we talked about DevOps best practices and like how I wanted to make sure I folded that into what I did. One of the key components of DevOps is like, you should be able to push to production whenever you want. Like, just, if you need to fix a bug, fix a bug. And with the Microsoft Store, they hand approve every update you send. And so there's like this unknown time between pushing to the Microsoft Store and it actually being pushed out to the edge device. And I wasn't too happy with how long that took. Like, it was variable, first of all. Like, it wouldn't happen within an hour. It would happen within 24 hours. Maybe it happened within 6 hours. Maybe it would happen within 24 hours. I never really knew. So I was like, okay, I got to get away from the Microsoft Store. I'm not happy with that update process. Well, if I'm trying to productionalize this, there is no other way to do that. To send, there's no other good way to send the app updates to Windows 10 IoT Core other than the Microsoft Store. Like, you can use Intune and stuff like that, but so I'm like, let's just no, we're gonna move away from that. And I also found out that I had some really weird sensor needs. Like that prototype sensor was actually a humidity and temperature sensor. And because it's a humidity sensor, and because of the way it's plastic, I can't just dunk that in hot coolant in my 1988 Ford Bronco 2. it's going to melt, first of all. And second of all, it's not meant to measure water temperature, it's meant to measure air temperature and the humidity. So I had to use another sensor. And I had some pretty crazy constraints. It had to fit in my Bronco. It had to be water tight, water resistant, and it had to go up to really high temperatures, like 250 degrees minimum Fahrenheit. And it couldn't be too expensive because I'm not super loaded. And it had to update relatively quickly. Like it couldn't take, 30 minutes to update its temperature because by then the car would be overheated by then. I'm using an extreme example, but different sensors update at different rates. Like some happen within microseconds and some happen within seconds and some happen within tens or dozens of seconds. So all of these different constraints led me to choosing between only a few different sensors in the real world. And I had one other constraint, because I am using a Raspberry Pi, which I could move away from that, but because I'm using a Raspberry Pi, its inputs are not analog. It has no analog inputs. It has a GPIO, like general purpose input output, so it's got all these pins that I can send data into from any sensor, but it has to be digital data. And the sensors that I found, the digital ones, use something called the one-wire protocol. And the crazy thing about the one-wire protocol is it moves so fast, like it oscillates its wave. Well, it oscillates its data rate so fast that me using C# at a high level can't directly talk to it because it can't read it fast enough because it's a managed language. It's not like C or lower level languages where I have more control over the timing. I don't have control over the timing in the C# layer, or the layer that runs. So I have just a bunch of different issues that I ran into in the real world. And the life lesson really isn't these specific issues for you. The life lesson is when you want to go from a prototype to production, you're going to run into things you don't expect. And that's what I ran into. Yeah?
Did you use an Arduino microcontroller for that? An Arduino microcontroller?
I could use
that would be the analog.
Yeah, so you can use an Arduino microcontroller. I had many options at that point. One of which could be an Arduino microcontroller between my Raspberry Pi and the actual analog sensor. I could use an analog sensor, and I could use that Arduino, which runs really, really fast and has analog inputs and digital outputs to translate that analog signal into a digital signal. I chose to go a different route. So this one-wire protocol, I can't communicate with it directly. So what did I do? I just threw everything, all that work that I went into putting into the whole other platform, I just threw it out. I said, no, we're not using it. We're gonna have a new setup. So instead of using Windows 10 IoT Core as the operating system, I'm gonna use Raspbian. Instead of a UWP app, I'm gonna run it on Microsoft Azure Iot Edge, which runs on Linux or Windows devices at the edge. Raspbian is a flavor of Linux that is built specifically for Raspberry Pi. I'm going to distribute it to the Azure Container Service, which runs in Azure, and every time I distribute it to the Azure Container Service, my Microsoft Azure IoT Edge is going to go to the Azure Container Service, find the latest containers, and update itself. Because Microsoft Azure IoT Edge is basically something Microsoft built that holds containers and orchestrates them. It's kind of like a cheap knockoff of Kubernetes, but it's built for Microsoft, or it's built for IoT specifically. And it's built to run on one device, unlike Kubernetes, which can distribute among many devices. This is the same though. Visual Studio Code, still going to use that to develop. Still obviously source controls Git. I can still build and distribute it through Azure Pipelines. So this is like where I'm headed towards now. So I had my prototype working, but because the real world with the sensor and with how slow it was to update, I'm completely changing the underlying implementation piece. So now this is kind of what the new setup is going to be. The Bronco has the sensor, the sends it to Azure IoT Edge. Azure IoT Edge processes it and sends it to IoT Hub, which is Azure's proprietary specialized communication platform between devices and the cloud. So if you ever do an IoT project in Azure, you'll probably run into IoT Hub, because that's like, whether I was using Windows 10 IoT Core UWP app, or I'm using Raspbian with an IoT Edge underlying thing, whatever's running at the edge, it needs to communicate with the cloud. And in Azure, IoT Hub is the way to do that, to tie those two things together. So then I needed to figure out how I'm going to update this. And I talked about it a little bit before, but develop in Visual Studio Code, send it to GitHub. GitHub triggers Azure pipelines to build and release it. It's built and then released to Azure Container Service. And then Azure Container Service is updating Azure IoT Edge at the edge. And this arrow actually kind of points the other way, because rather than pushing it to the edge device makes a request to the container service every once in a while and say, hey, is there an update? Hey, is there an update? Because in IoT, just in general, you want your edge device to have control over who it's getting updates from. You don't want to have somebody like take control of this and then start sending its own updates to the device from like a different place. It's just a security.
How frequent is the data post from the device?
How frequently does it ask for updates?
No, once it's running on Raspbian,
Yeah.
how frequent does it post data to cloud? Like,
It's dependent on your application.
Yeah, you can decide how frequently that happens. So, great question. And I know that not everybody's in this, and I may gloss over things you don't understand. If that happens, please ask, because I understand what I built, and I'm probably glossing over lots of things because of that. Or at least I partially understand most of what I built.
The
Yeah.
reason is I saw Azure mobile functions in other layers, and I assumed it was the data being posted from the device rather than it asking for an update from the Azure Container Service. Like once the device has read temperature from the module, it's gonna have to post the data back to the cloud.
Yes.
So is that the function which does it, or is it something else? Is it a small console application that you keep running in a loop?
So, good question. I'm going to dig into it a little bit. So, Azure IoT Edge is like a daemon. No one sees it, doesn't have a GUI. It just runs on a device like Raspberry Pi. And its main goal is to be a platform. And the platform maintains security, makes sure it's up, has monitoring built into it. That's its role. Azure IoT Edge, on top of it, you put your modules, or modules you grab from other people. And these modules can do whatever you want. You have control over them. Some of them might save log files on your device. Some of them could have machine learning in them. Like if you built machine learning, if you use machine learning in Azure, you can take that same end result and then put it into your device as a container. I haven't done that yet, so I may not understand how all that works. But basically, you have all these different containers running on top of the IoT Edge runtime. And they all communicate to each other over a bus. So how that works is, it's like you have rows of houses on a street. And each house can do different things. Maybe Joe Schmo at house number 1 is really good at making pancakes. But Joe Schmo at or Bobby Sue at house number 2 is really good at putting syrup on pancakes. And so, you know, you get your pancakes made, and then you go out to the street, walk along the street, and then the second house is like, hey, those look like pancakes. Can I have some pancakes? We're going to put some syrup on them. And then they walk in and you put syrup on them. So each house has its own role, like each module sitting on top of Azure IoT Edge has its own role. And they communicate to each other, like people walking in and out of houses, and you can get those to do whatever they want. In my case, I'm going to have a module, and I say going to intentionally because we haven't got there yet. Like I said, this is like in progress, you're looking at a very raw, like this is not a polished thing. This is still in development. But I'm going to have a module that reads the temperature. I'm going to have another module that sends that temperature after it's read and understood to mean something to Azure. And that's pretty much it. We have two modules. One to read those modules. This is where the container service comes into play. If I want to update one of those modules, all I need to do is update my Azure container service with the newest version of the module. And then this device goes out to Azure Container Service and asks, are there any updates? And if there are, it pulls it down and updates itself. And that's also another function of Azure Iot Edge runtime, is it's providing that capability. Does that answer your question?
Yeah.
Cool. And because I can write whenever I want in those modules, I can make that as frequent or as slow as I want it to be. If I want to update the temperature to the cloud every minute, I can make it do that on a timer. If I want to do it every second, I can also do that on a timer. It's up to me. It's also up to how many messages I want to use in my IoT Hub instance, because you're charged like per message.
So you can have the control, like totally ignore the messages from the sensor. And whenever the temperature is going above or below the threshold, at the time you can send it to the upstream. Basically,
Yeah.
IoT Edge runtime is like a logical module separation, so that you can create like a multiple micro module specific that is doing like setting task, and you can communicate between the models using the service bus. And whenever it's required, then you can send it to the upstream, which is the IoT message.
Yeah. He knows more about it than I do at this point, so this is kind of where I'm at on my journey. So I've got some hardware, made some code, set up continuous integration, delivery, and then this doesn't matter anymore because I'm not doing it. So I'm working towards moving to Azure IoT Edge, and then I'm going to do the rest of these things. And we'll get back to this. So I want to show you, put a little meat to this. At least I want to show you what this all looks like in code and pipelines and all that stuff. And talk about it a little bit more. So I'll come back to this slide. Actually, so I know it's blurry, I know it's not going to be super clear, but we'll talk through each part and hopefully you'll get a good idea of what's going on. So first there's code, right? So don't worry about what this code is, just know that it's code. We have code, it's a module. The module is going to read the temperature from the Bronco. This is future future. I can read the temperature, we'll talk about that in a second, but it's not yet being read by IoT Edge. I'm just reading it from the console right now. My next step is to take that temperature that I know I can read from the console in the Raspberry Pi, and instead read it from my Azure IoT Edge module. So that's what I'm working on. Let's pretend I did that for fun. And I'll represent that by just adding a new line to this file. So we have a change, and I'm going to check into Git. So, updated. And now this is where we get into the Azure part here at Global Azure Bootcamp. So let's talk a little bit about Azure.
Jared, can you increase the font size?
I can, but I'm not really showing you what's on the screen.
Okay.
It's code. It does code things. That's all we need to know. So, how many here have used Azure DevOps by any chance? Cool. That's about half. Oh, we've got Justin back there. He's used it. You've used it? That's surprising. So, in Azure DevOps, for those who haven't used it, you can store your code, which is great. I'm not storing my code there. I'm storing my code in GitHub, but we just know, I don't know if you saw this, but it went from 4 to 5 commits. And if you look in there, just to show you there's no smoke or mirrors, we updated a minute ago. You just saw that update. And that update is triggering a build in Azure DevOps, or rather Azure Pipelines. And why we want to do that, for those who haven't used Azure DevOps, we want to have a CI/CD pipeline be able to push to this device. And we're pushing not directly to the device, but to the container registry that lives in Azure. And so in order to do that, we need to build the module that we just created in Visual Studio Code, which I didn't show you the code specifically, but I have a module that's going to read the temperature. I want to build it and send it to the container service so my device can grab the latest version. So I have a build to do that, and we can look at what that build looks like. So in that build, it's very simple. We have a task called Azure Iot Edge build module images. Makes sense. We have another task, Azure Iot Edge push module images. No points for guessing what that does. And that's it. So in here, I just have it pointing to my subscription, my Azure container registry, and what file describes what's going to be pushed. And the platform, which is ARM32, which is really interesting because that platform is what's running on the Raspberry Pi. The Raspberry Pi is an ARM CPU, and it's 32-bit. That's really interesting because when you need to build for that device, you need to use an ARM32 processor or an emulator to build it. Well, Microsoft doesn't provide build agents to build for that platform. So I have a solution. Not just me, but there is a solution. So in the pipeline, it failed, but I'll show you why. It's unable to locate an executable file called IoT Edge Dev. Where is it unable to locate that in order to build my image to be able to send it to the container registry for my device to go grab from the container registry? Where is it trying to build that image? It's trying to build it right on this Raspberry Pi that you see before you. This little tiny device is acting as my build agent to build my module to then send it to Azure Container Registry because it needs to build it on a ARM32 thing. And what this is yelling at me about is that I don't have the right dependencies in that device quite yet. But it literally, as we were talking, Azure DevOps sent a request to my Raspberry Pi sitting right there to build my image and then take that image after it was done, if it were to finish, but I don't have the dependencies in there yet. It's just crazy to me. So I installed a build agent on that.
So your Pi is connecting as an agent.
Huh?
That is right. So your Pi is like a VSTS agent, so that it's connecting to the cloud.
Yes. Yeah, my Raspberry Pi is like a...
Yeah, there is another approach we can use for this cross ARM builds. So there is a QEMU emulator. So even in the Linux hosted stuff, you can copy the script where you can emulate the ARM QEMU, so that you don't need like any Raspberry Pi to do your ARM build. So you can configure that in the Docker script, the Linux Docker container script, so that in your Linux hosted machine itself, you can copy that emulator script and all, and you do all the ARM builds. But you need to stage like a multi-stage Docker build, so that like you are doing the emulator build in like one stage and copy that output into the container and build the container. So
Okay.
yeah, if you go to that Baleno library, they are having like multiple Docker. That's the one other step, because initially I did build using this kind of Raspberry Pi, but that's not good enough to do like the production kind of builds,
Right.
because it needs to be connected always.
Are you
and
saying I
everything.
shouldn't use Raspberry Pi to build my production?
You can do
system?
that. So one option, but when you are going for like
Yeah.
the production build stuff, then we cannot make sure like always there is one device doing all the things.
Okay, there you go.
Yeah.
See? V2, yeah, thanks. That's helpful. So, like I was saying, you can use an emulator. I didn't know how to do that necessarily, but you can use an emulator to build these images too. Sounds like that might be easier, or at least more production-ready result. Because if you go to a company and you say, in order to build, you need to get a stack of Raspberry Pis, like that might not be the best way to do it. So anyway, I think that's pretty much it. And this is literally the device I have. I can talk more about the hardware. I could just answer questions. I know this is an Azure, global Azure thing, and I didn't really dive deep into the Azure side, so if you have more questions about what that looks like, I'd be happy to answer those.
I want to look like how the deployment that happened for the IoT edge deployment, because we are building this into the Azure container images. How we can specify like what are the devices that should go for this deployment kind of stuff. Not just like a blue-green deployment. I need to deploy updates for like a certain devices instead of like all devices. Based on your thing, you said like it's doing the pull-based updates, right? How I can prevent like I have 100 devices, but I need to do like a deployment on 5 devices
Yeah.
first. Then
So you want like an inside ring?
yes,
like
I
inside.
need to do like some pre-deployment.
Great question. So how I would set that up personally, which there could be pros and cons to this approach, and I haven't done it, but I've seen success in other paradigms by doing this. So you can have the same build, one build, and then you can set up, let's say, 3 separate releases. And in your 3 separate releases, you have 3 separate resource groups in Azure. You have your dev resource group, your test resource group, or QA, and your production resource group. In each one of those resource groups, you have your a reference to, I'm not sure if you'd have a container registry for each one, or I think so, yeah. You'd have a container registry for each one. Your test devices, or your dev devices, you have hooked into your dev container registry. Your test devices, you have hooked into your test repository, and your production ones in your production ones. I mean, that's like a very brute force method of solving that problem, like, but it's also effective. So take that. Whatever.
Yeah, but it would be contained like so we need to make sure like these are the test devices.
Yep.
And these are the production.
And you can add as many test devices in the future as you want. Just point them to that container registry in your test resource group.
Yeah.
And then you'd have 3 releases, and then you'd have a pipeline. So you automatically push to dev all the time, and then have an approval gate between dev and test, and an approval gate between test and production that hopefully is only open to the people who are allowed to make that call, or group of 80 people that are allowed to make that call. Any other ideas from people who have been there, done that? Not be wrong about it, or at least have better ideas. Does that answer your question? Yeah.
You mentioned you had an issue with the analog input from the sensor, and you
Yes.
didn't use an Arduino to get
Yeah.
around that. What did you use to be able to read the analog input?
Great question. Okay. That's a good question. So this is a digital sensor. I did, in my hands, have an analog sensor at one point, and I read online that the analog sensor is really finicky, like there's a lot of noise, because analog in general has a lot of noise. And this being in the environment that it's going to be in a truck, without a really steady power source, and with a bunch of other electrical noise going on, I figured analog's probably not going to give me what I need. So what this does is, like, every sensor at the very edge is analog. It's just, when does it turn digital? Like the real world is analog. Like, we're feeling things, temperature. So at some point it's got to go from analog to digital. The difference between an analog sensor and a digital sensor is An analog sensor lets you make that decision later. A digital sensor makes the analog part that's reading it turn into digital right in the sensor. There's actually a little tiny computing device in here that turns the analog signal to digital. And every digital signal has some sort of standard or protocol. Zeros and ones at some point, at some level. But at the end, we have to understand what those zeros and ones actually are. And so there's different protocols. In this case, this digital sensor turns it into the one-wire protocol. Fancy. The trick is, the one-wire protocol, why it's called that is because you can have a bunch of sensors all lined up on a string that can be independently looked at, but it's all on one wire. So you can have 5 sensors on one wire. Isn't that cool? And one of the thing is, whatever's at the end has to be able to understand the one-wire protocol. In my case, because at the very beginning of the project, I was saying I was using Windows 10 IoT Core, Windows 10 IoT Core has no native ability inside of it to understand what one wire is or what it does. There's workarounds, whatever. I didn't like any of the workarounds. What is really cool about Windows 10 IoT Core, though, is that it can read another protocol called I2C. And so what I did was, I found on the internet, you guys are familiar with the internet, there's this little tiny piece of hardware device that takes one wire and outputs I2C. Both digital protocols, but one I knew I could read and one I couldn't read. So that's what it does. All it does, translate one wire into I2C. And so both Windows 10 IoT Core and Raspbian has the built-in ability to read I2C. So I was like, okay, well, either way, whatever operating system I end up with, once I have this piece of hardware that takes one wire and turns it into I2C, I can read I2C. And it turns out to be the case. With that piece of hardware, that's all its job is to turn one wire into I2C. I can log into my Raspberry Pi, go into the command line right now, and read the temperature. So I feel really, really excited because the next step is to take that same command line call, basically, make it happen inside of a module that lives in Azure Iot Edge, and then take the result and send it to IoT Hub, and then read that result and output it somewhere. IoT Hub, how many people have worked or heard? How many people have heard of IoT Hub? Cool. How many people have used it? Cool. So one of the things I thought when I started using IoT Hub in the past for other projects was, oh, I'll just import it into anything. Well, it's true that you can take IoT Hub and import it into anything, but it needs to go through some sort of intermediary step of some sort of stream or pipeline. So my go-to now is directly read IoT Hub using Stream Analytics. So whenever you have IoT Hub, think, man, Stream Analytics could be useful here. And what Stream Analytics does is it's based on the name, diverts the stream of data coming in. So you can divert it, you can take the whole stream of data and pipe it into blob storage, for example, or a database or wherever you want, or you can just take the important bits. So like, I don't know, somebody was saying, if it goes over a certain threshold or below a certain threshold, then we want to update something. You can do that at the edge, or you can do that in Stream Analytics. Like if you want a history of all the data, and you don't want to lose any of it, then you can send all your data to the cloud, and then use Stream Analytics to divert all of the data to a storage place, and then also divert the very important pieces when it's like above a threshold or below a threshold to an alerting system. And then you could like use logic apps to send an email or send a text message or something like that. So once you get the data to the cloud, like I think the first stop that's most useful is Stream Analytics, just because it makes it easy to divert that stream of data wherever you want it to go. So yeah. So this hardware part is the part that's sucked up the most of my time because I'm a software developer and this is all very alien to me. and there's many options, and not all of them are clear about why one is better than the other. So if you ever get into doing stuff like this, find a hardware friend first of all, or come to the Orlando IoT meetup. We got lots of hardware friends there. So, yeah. Any other questions? I think I have 3 minutes left, although I started a little late.
Yeah, you can continue if you want to.
Okay. Well, I'll take any more questions if anybody has them. I know this is a lot.
Oh, can you talk about Azure Iot Sphere?
Sure.
Just like, how do you see it fitting into this project? Like, since it's a more secure version of
Azure IoT Suite.
Sphere.
Sphere.
Yeah.
Oh, okay. Okay. Yeah. So there's like a ton of Azure services for IoT. It can be confusing to figure out which one you need and why and when and how. Thankfully, at my website, which I'm plugging, if you scroll down past all the Bronco stuff you should read, then you get to even more posts. I promise this leads somewhere useful. So I wrote a Microsoft IoT Quick Guide, and if you're wondering what Azure stuff is there for IoT and why would I want to use it, what does it work with, this is a great blog post for you to go find out what each thing does. So we have IoT Hub, we talked about that. Azure IoT Edge, we talked about that. This thing I got confused with your question about because I thought you'd said Windows 10 IoT Core, which I dismissed. Go away. Windows 10 IoT Enterprise, which is actually just Windows 10 IoT Pro with a different license. Azure IoT Central, which is Microsoft's SaaS solution. Azure Sphere, which you asked about, which we'll get back to. We'll not get back to. So Azure Sphere is Microsoft's kind of all-encompassing platform for IoT development, specifically for low-power devices. So the devices you have like in your microwave or your refrigerator or whatever, and even more so distributed throughout the world in places that no one can think of or no one thinks about. Let me start with the problem. So we have tons and tons of little tiny devices, little tiny embedded computers across the world, billions of them, and not many of them are connected to the internet. I think 2% are connected to the internet, according to Microsoft. And some of the issues with that are that eventually we want to connect more and more of these things to the internet, where it makes sense. But in doing so, there's a big security problem because these little tiny devices are not that powerful. And so some of the security stuff that we want to do, like cryptographically securing things, takes more computing power than these things can provide. And because these embedded device manufacturers have been building these things offline for so long, they haven't really thought about the security concerns that we all think about as people who work in the cloud. All that OWASP stuff, all that, threat detection stuff, monitoring stuff, they don't think about it. And Microsoft Research identified 7 properties of companies who've connected these tiny devices to the internet and been successful and stayed secure without a bunch of hackers getting into them. They looked at all those different projects that have been successful and said, what is common about these? And they figured out 7 properties that make them successful. I don't know exactly what they all are. But after Microsoft Research did that, Microsoft said, great, let's show the world how to actually build a platform to make this happen. And that is Azure Sphere. So they built a hardware reference design, physical hardware. And they said, here's how you build secure hardware. And then they put an operating system on top of it. But because Windows is super heavy and it won't work in an embedded system that's so tiny and low power, they forked Linux to do it, which is really crazy because it's the first time in history Microsoft has forked Linux and made their own operating system based on Linux. So they put their own version of Linux that had been hardened on top of their reference design. And then they said, okay, we're going to make it easy for you to connect to the cloud and update your stuff. And And so we'll set that up too. And I put all that together, and they're basically giving away the hardware designs. They're giving away the operating system because they have to, because it's Linux based, and that's part of the licensing agreement of Linux, in hopes that a bunch of manufacturers adopt that and then start using Azure and giving them a bunch of data and they can make a bunch of money. But it is actually really cool because Microsoft is so advanced compared to these embedded manufacturers that they have a lot of information that these embedded manufacturers would take possibly a decade to learn, and they just said, here, we did it. Go take this and run with it. And so I'm excited to see what happens with Azure Sphere. Microsoft is really buying into the IoT space. Like I was just telling Mikey, they just bought a company last week that makes embedded operating systems. And the embedded operating system they make is called ThreadX, and there's over 6 billion installations of this real-time operating system for embedded devices out there in the real world. So my little joke is that Microsoft's most popular operating system went from Windows to something no one's ever heard of overnight by buying a company. So it's out there, it's happening, and yeah, exciting stuff. And also this project is, you're catching me in the middle of it. I wish I was much more further. I wish I could have a very polished talk where I talk about how I figured everything out and I'm an amazing developer. Maybe someday I'll give that talk. For now, it's an ongoing project, and if you want to know more about it, that's where you can go. You can find blog posts there, you can find the code there, and if you want to start your own project, and you don't want to fall into the dev trap that I fell into of trying to figure all this stuff out, you can just get a starter kit. It's a really good place to start. And you can just Google Microsoft Azure Iot Starter Kit, and you'll find something like this, a page something like this, and buy it and try it out. It's a good time. And if you want to find me on Twitter, @jporcinelli. If you have a hard time with spelling, like I do, like I did for the first 5 years of my life when I tried to learn how to spell my name, then you can take a picture. Yeah. Thanks. Thanks for your time.
Thank you, Jared.